Thank you. Appreciate the opportunity to come speak regarding this topic. Been to the Reclamation Conference a few times and wasn't sure I was going to have this opportunity. So we're going to talk about a produced water release that occurred, we call it the Goliath West Lateral. Little site background, August of 2022, we had a produced water release at our facility from a 6-inch pipeline. It was 34,000 barrels, and it impacted approximately 6.5 acres of agricultural land. You saw in that first picture, that's the general area. We broke it into 3 zones. We'll talk a little bit about that as we managed the release, the repairs, and the remediation. So initially, we shut the pipeline down. We isolated the leak, made the repairs. We did some initial excavation of the soil so you could get to the pipe, make those repairs, get rid of any subsurface initial impact that we could get to. And so, as it says up here, the initial excavation was about almost 34,000 tons of impacted soil and 4,400 barrels of produced water in impacted groundwater. So as I said, we broke it into 3 zones. I'm going to try to walk over here for those you can see it. The first zone is parallel with the line. The release point was up here to the far west of the area, and the release followed the topography along the road into this natural little bowl filled up there, and then reached the rim of the bowl, and then went out into the agricultural field. That's zone 3. So again, we have zone 1, which is the initial release point, zone 2, where it kind of pooled, and then zone 3 is it went out into the farmer's field. So the initial response was submitted to DEQ August 23rd. We started the assessment activities August and September. And then the first thing we did, which, we'll talk a little bit about this. We want to utilize science to understand and the technologies that best can be used at this site. So we performed 18 ERT transects and 2 electro-EM surveys, and that gave us a footprint, horizontal footprint, vertical footprint of what the release area was. So we used that, and we're going to show you a couple of the surveys. We used that to guide us with this installation of these 59 borings, 42 wells, and that helped confirm what we knew from the surveys, that we had the proper capture zone, that we had it delineated, and we could use those points again to ensure that we weren't losing migration of the release point. So again, we knew the groundwater flow was to the northeast, and from these wells tying in with the surveys, we were able to make sure that we had the footprint correctly. So here's the image of sorry for you guys over here, but here's the image for the survey, zone 1, zone 2, zone 3, and you can see the various transects that we used. Red, meaning we're getting higher readings where the impacts were. The blue, the cooler readings, not getting the impacts. So just to give you a quick idea of what this looks like. This is zone 1. Again, this is the initial area where the release point was. You can see basically the impact is about the first 15 feet. And this is looking down the release. So it's about 15 feet and it's pretty wide area. Then when we get to that bowl, you can see it's goes a little bit deeper, maybe a little about 20 feet. And then as you get out to the farmer's field, it was very, very narrow as it went out into the field. So again, this was critical to the start of the project to really understand where the release was, and then we could put the wells and the borings to ensure that to verify this data and ensure we had that area captured. So we started working with our corrective action plan. There's a couple of key points to this. We did consult with Dr. DeSutter, who I'm sure most of you know and have met, on the soil washing and adding calcium amendments to the release area. And that was important to us, as well as obviously working. We had a meeting at the DEQ's office. We met with DEQ, NDIC. Again, Dr. DeSutter was helping us, trying to utilize as many resources as we can, third parties, to ensure that we were really not missing something. So that was a big help for what we needed to do as we developed the plan. Remediation plan was submitted to the DEQ in October, and then we started almost immediately with the corrective actions, and we got those through December. It was a bit of a race to try to get it done before the winter really rolled in, and it made it more complicated. Again, the goals that we discussed with the agencies, and we've talked about this a little bit yesterday, and you hear this is a reclamation conference. We really wanted to preserve the native soil as much as we can. Don't excavate any more than we needed to, and we wanted to just kind of reduce the amount of waste. So, and we wanted to get that zone 3, the agricultural field, back to production as fast as we could. So what we basically did was we took the zone 3 soil, we dug that zone 3 soil, we mixed it with some amendments, gypsum and straw. We blended it in from the zone 3, and we used that as backfill from what we pulled from zone 2. Zone 2 we disposed of. We went out into, and we also used some of the soil from the farmer or the property owner's fields out there as our backfill, clean soil, back into zone 3. So zone 3, we were done pretty quickly to try to get that back as quickly as we could to use out there. So again, zones 1 and zone 2, we also, and this is important too, it wasn't just trying to get the amendments in the soil into the field. We had to have an infrastructure out there so that you could get water retention, you could get some injection points as you put your calcium acetate into the system. So a lot of times you hear people that it's just really trying to get the soil out, get the gypsum in, get the soil back in the hole. But the infrastructure was important to take the time to make sure that was done correctly. So we did have this subsurface injection system in zones 1 and 2. We had 31 50-foot horizontal injection wells installed 4 feet below surface. And then we backfilled 2 feet of pea gravel and geofabric so that you didn't get it all silted up, binding up so that you could, again, get that water and the acetate to flow through your system and out and cover as much area as you can in zones 1 and 2. And again, it says zones 1 and 2, we had used 492 ton of flue gas gypsum and 10 tons of the calcium acetate. And yeah, so again, what we talked about, here's your we have your injection wells, you've got your laterals so that you can, and you got your recovery points, 3 in zone 1, 1 up in the corner of zone 2. It's just a quick image of what we're looking at with the collection pipe, with your pea gravel, with your fabric to ensure that you get enough to get the water and the acetate through the system, and you get some retention time. The retention time is critical too. So here's another for zone 2, showing you the images of how we had that with the 3 laterals. Here's just a quick shot of the construction work that was done with the piping. Again, this is another image where you can see how as the zone goes through and out into the farmer's field. Straw and gypsum in zone 2 that we mixed, and zone 1 gypsum, just another visual what you can see out there. And again, the injection trenches, kind of hard to see, covered in snow out there in zone 2. Again, we were some of the critical points that we talk about, we work closely with the DEQ, Dr. DeSutter, because it was a race to get this out there, get a system installed, come to some agreements of what we wanted to get out there before we started getting too much snow out there. We were working pretty hard right up through December. So again, zone 3, we're pretty much we completed the remediations, and we returned that land use for ag production. You didn't get as much the first year because you've altered the soil. You have to give it a little bit of time to get back. But again, we've done some post-excavation sampling. Looks like everything is as we expected. The soil is in good shape. We're not getting anything outside of that. That footprint is showing that everything's clean. So we basically returned it for agricultural use last year, and he's been farming the area. I think you'll see a picture. He's got some soy crop already growing pretty well out there. Yeah, so there's zone 3 again. All right, zones 1 and 2. We utilized, and I think we'll try to go through this as quickly as we can, but it's a lot to cover. We wanted to implement the soil washing, utilizing the calcium amendments, freshwater application. Again, treating from the top down, as we would get the calcium acetate, the water, let it flow through the system, through the infrastructure, through through the infrastructure, the injection wells, the laterals, and then we could get it to a collection point where we could take that impacted water and haul that out. So again, we've recovered so far in 1 and 2, almost 49,000 barrels of groundwater recovered, 26,000 barrels of fresh water applied. Talk about 51,500 barrels of stormwater captured, and we've used the 25 tons of calcium acetate. Now, again, what's interesting to note, stormwater captured, we built some berms up around that zone 3 to try to keep the water, the rainwater, the snow, try to just keep as much water and flushing as we can. So utilizing some of Mother Nature as well as any water that we've brought into the system. So, so these 2 pictures over here, when you see the amount of water that's sitting on there, is really a great shot. It shows the the amount of water that you're using, that you're flushing it, you're getting water retention, and then your acetate retention throughout your soil matrix. So those are pretty powerful shots as how much water we have. Got to keep, that's the goal, right? You got to get as much water as you can, flush as much as you can throughout the system. And as we talked about, we're starting to see summer 2024 in the upper right-hand corner, we're starting to see some plant growth. And then bottom right-hand corner, that's the soy that the farmer has been growing out there. So he's been able to utilize his property pretty quickly. So let's just talk quickly about what we've had to do out there, our performance. So we look at SAR, which is your sodium absorption ratio, which is the measured amount of sodium in the water in the soil as it relates to calcium and magnesium. Higher SAR, you get like a sodic soil. It gets the soil structure starts to cling. You don't get the plant growth, so you need to kind of break it down. That's what this calcium acetate's doing. We could talk. We could talk about the chemistry about this, but it's pretty. It can be a bit complicated discussion, but it's really all about trying to get the. Make sure I get this right. The sodium out of that from adhering to the clay matrix, so that you can break that down and wash it through the system, so that you can get it out of the soil in your water matrix, right? So you're dislodging it, utilizing this calcium acetate, and the acetate is very soluble, so it gets into the system, runs through there pretty quickly. So I'll try to go through this quickly because I do want to share with you some of the numbers at the end. But we are doing quarterly sampling, semi-annual sampling, both with the groundwater and with the soil. We've got, again, number of wells out there, 16 monitor wells, piezometers, recovery points, where we're taking our samples, making sure, again, that any impacts we have are still within that footprint, which is important, and it is. And we're making sure to show progress, getting that soil back to a condition where it can be used. So a lot of data. This is, I expected anybody to read it, but we collect a lot of data to compare all this, the performance, to make sure it's looking good. So just to give you an idea of the numbers, in 2022, our chloride concentrations ranged from, you can see the numbers, 556 to almost 18,000. I'm sorry, in 2022, we started at 132,000. This last sampling event, we've reduced it to anywhere from 556 to 18,000. So significant decrease in our chloride concentrations. Again, this is just soil. Again, our SAR value, which we just talked about, sodium absorption ratio, it was at 71 when we started, our baseline. We're at anywhere between a little more than 4 to 34, significant drop. And then the soil conductivity, again, started at 211, and we're down to anywhere between a little bit less than 5 to 75. So significant reductions in the soil over just the 2 years. Same thing with the groundwater. Again, we've got a maximum chloride concentration we had in 2022 of 90,000. We range from anywhere from 26.5 to half of that 90,000, 40,000. Again, the conductivity, 182, starting in 2022, and we've dropped it to half, to almost a little more than 4, a little less than 4. And again, we're seeing that the washing activity is mobilizing the impacts through the system, and we're capturing it. again, this is the last. I want to save a couple minutes if you have any questions. This is the last chart, and what we're trying to show here is, again, we're talking about sodium absorption ratio. We're just looking at one of the borings, SB 56, and you're seeing in the root zone, again, your SAR started off. By the way, the lighter one, 2023, you see everything's kind of over to the right. High sodium absorption ratio throughout the soil column. You can see in the 2 years, we've pushed that to the left to reduce it closer to 10 up in the root zone. Again, that's so you can start getting the soil back to being used. And as you push that through the system, the sodium through the system, you get this peak to the right, and that's going to come back. But back in the subsoil, it's come down, pushed to the right. And then when we're collecting it down in the water-bearing zone, way over here, back to the left. So what you're really seeing, really what the point of this chart is to show that you're pushing sodium down from the root zone through the column, and you're capturing it. Again, not trying to overemphasize, but the importance of having that collection system so you can collect that water and pull it out through the system. So, there's, I think some of the most important things for people to understand, you've got to have, you have to make sure you take the time to correctly install a system, delineate your extent of your impacts, so you understand what you're dealing with, and then let the science drive what you're doing from there, whether that's the amount of the calcium acetate impact, calcium acetate injections, whether it's the amount of water, and ensuring that you've got that footprint kind of under control, which we have. And you got to work with the agencies, and again, with whoever expertise, to make sure you're kind of all on the same page and you understand what your goals are, get this land back to its usage, and there you have it. So I'm sorry, I went kind of fast. Thank you, by the way, for the applause. If you have any questions, if it's a little more in depth, happy to talk to you afterwards, but anything, because I know the science can be kind of complicated.
Tell us real quick what the actual operation looks like as you're injecting. I assume you've got the calcium acetate in solution, 100 barrels at a time, or you flood everything and watch the level, or?
Yeah, we've actually burning time. Okay, we've actually done both, right? We've spread some of this calcium acetate, and then we've sprayed water over it to try to get it into a mixture, so then it goes down. Now, the first time we did it, it's very fine. It's almost like powdered sugar. So we were running into a bit of a problem with containing it right into that area. So we're gonna get it into solution, push it through the injection points so it gets through that column and spreads out in there. So I hope that answered your question. I think the best way is, I think we've learned the best way is in some form of a solution, so that it's a little easier to manage as you're trying to spread it across the site.
But why on top?
We've done both.
So huge declines right away, basically looking at this, to keep going down, or is it kind of plateauing off now?
Well, actually, at first you kind of see it stay high and spike up because you're releasing all this sodium out. But we're starting to see the decrease now. As you can see, it's moving over to the left, but you're seeing this high increase in the subsoils because you're pushing the sodium out. So you're still seeing some increase, but again, we're capturing it and pulling it out. Yeah, I think initially you're going to see a spike, if you will. Yeah, well, and we've been talking about going back out and not just using this data, but also coming out and doing some more EM surveys. Now, again, you've altered where you've pushed the sodium, so you got to be careful what you're looking at, that when you're looking at it, you're understanding that some of this is maybe higher because you've mobilized it, if you will. So, yeah, but you shouldn't, I wouldn't say you should be nervous when you first see that spike, because you're releasing everything into the environment, so. Yeah, actually and that's sometimes tough to discuss with management when you're trying to explain to them, hey, this increase is a good thing, because they want to see it, just basically a linear, it just drops, but it's with any of these kind of things. You'll see a spike initially as you release the stuff, and then you capture it and it comes back down. But you're right, it's working, and that's sometimes a difficult conversation with whoever you're talking with, to explain to them that spike is expected and is actually a good thing.